This video is sponsored by Squarespace, the all-in-one platform that makes it easy to build and manage your online presence. We'll have more on them later, but for now, welcome back to the JMZ Online YouTube channel. Let's get into it.
All right, so we're back here working on the 396 big block. First thing we're gonna do here is rough bore our sleeves for our pistons, but we're also gonna be going through the process of decking the block. Now, a lot of you commented on the first video about how we did all this work for a numbers matching block, but how are we gonna deck it and not remove the numbers? So we're gonna be showing you that process here, but we wanna take as little material off the decks as it takes to clean up and square them up. So the first thing I'm gonna do here is measure our two different deck heights to figure out which side is taller, because we wanna start on the side that is already shorter, clean up just as much as it takes to clean up, and then cut the other deck to match. This is our deck height gauge. Basically what we do is set it up taking into account the compression height of the piston, the center to center length of the connecting rod, half the stroke length of the crankshaft, and then we subtract half the diameter of the main journal down in the bottom, the main bore, so that basically this references the bottom of the main bore, and then our dial indicator references the top here. So getting about 8.324 here. Coming in 826, 326 or 27 here. So we're actually a little bit taller here than we are over here, which tells me that relative to the crankshaft, basically the deck is not perfectly parallel. So on this side, we're getting about 8.322, a couple thous shorter on this deck height. 8.323 there. What we just figured out is relative to the crankshaft center line, this deck height is already shorter than the other side. Okay, so now that we know we want to start on this bank of cylinders, I'm going to put the square in down here to get the block all squared up and level, and then I'm going to switch over to our boring head, set up a cutter, and we'll bore our first cylinder.
As you can see, the block fixture here references off of the main bore of the block and uses a precision square relative to the pan rail in order to make sure that the two banks of cylinders end up bored and decked exactly perpendicular to each other. It doesn't matter whether you bore the block first or deck the block first, so I opted to bore and then deck. Being a 396, standard bore size is 4.094 inches, and unfortunately the pistons we're using seem to be obsolete in standard size, so we're forced to make the block 30 thousandths oversize. We'll be boring the block in two cuts, one bringing us to about 14 thousandths below finished size, and the second cut bringing us to within 4 thousandths of finished size, leaving a small amount of material to remove in the cylinder home.
Got our finger in here so we can center up. I'm close, but I'm not perfect. I'm gonna call that good and lock the table down. Last thing I really need to do here is set my stop, so I'm gonna put a cutter in. And again, I've got that cutter set for our rough bore, because we wanna leave a few thousandths to hone. Feeler gauge.
With a 3 thou feeler gauge, I slowly run the spindle down until I just feel resistance on the feeler gauge, indicating that the cutter is about 3 thousandths from the deck.
So I wanna bore 6 5/16 based on that.
The machine has an automatic stop, which we're setting based on the length of the cylinder to avoid crashing into the main webbing in the bottom of the block.
Start around 480. Sounds good, looks good.
With the bore gauge set with 0 as our nominal finished bore size, we can see that after our first cut, we're coming in right around 14 thousandths under finished size, exactly where we want to be. Our next cut should remove just around 10 thousandths of additional material, bringing us to within 4 thousandths of our finished bore size, leaving just the right amount of material to remove in the cylinder home. The last step of the boring process is to chamfer the top edge of the cylinder to break the sharp edge and aid in piston and ring installation later on. At this point, we'll simply repeat the process on the remaining 3 cylinders on this bank. With all 4 cylinders on this bank board, we're going to go ahead and switch back over to our surfacing head and resurface this side of the block. Switching between tools is fairly quick and easy on this machine since it's equipped with the spindle caddy. We simply unbolt the spindle, set it on the caddy, rotate over to the next tool, and bolt it back up to the machine.
Okay, so we've got our CBN in here, our CBN cutter. We're gonna deck the block now, but we have to stop before we go all the way across this edge here because we don't want to take off the numbers. That's what makes the block valuable for the customer. I'm just gonna run over here and run down close with our cutter before I turn it on. Make sure this is pulled out so it doesn't start feeding. I'm just gonna go down until it just touches. Okay, I just heard it touch. Hopefully you guys can hear that too. We've just skimmed right there. You can just barely see where it's cut, that line. Same thing on the back side here. We've just barely skimmed. So that's our 0 point at minus 5.1875 on the Z. Did the same thing on the opposite end here just to double check. Z axis, we're minus 5.1870, so within a 0.5 of the other side. So that's good news. So I did a little bit of feeding it by hand on the x-axis here. Basically, I was just skimming it, and we got over to just before those numbers because we want to surface as far this way as we can. So we're going to stop there, and what I did is I put a 0 mark on the x-axis there on the DRO so we know where to run the cutter over to. That cutter probably needs turned. Kind of 2 ways I can stop it. I can either pull the stop on the wheel down here that disengages the table, or I can slow it down by basically slowing the speed of the motor to 0. I think I'm probably going to do it just by disengaging the table here. Right now I'm traversing the Z-axis to get as far that direction as we can. And we'll see how that looks. I don't know if that's what I'll do for the final cut or not yet.
Before we see how we did, let's take a quick break to talk about our sponsor for this video, Squarespace. I first designed a website for our machine shop using Squarespace clear back in 2015 because I knew we needed to start building our business's online presence. Squarespace makes it easy to build your brand with a custom domain purchased through the platform, and once you have a domain, the user interface is simple and easy to use even for someone with no web design or coding experience. Once your site is live, there's a full suite of analytics allowing you to get stats on your traffic to help you grow. You can tell here that our traffic has grown a lot, especially over the past 2 years with our growth on social media. Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/JimsAutomotive to save 10% off your first purchase of a website or domain.
On the first cut here, basically what we did, we had the block moved that direction as far, not as far as we could, but pretty far that way, so that the center of the cutter came to right here, because it's, you know, a circular cutter, so it's not going to cut straight across. So we brought it out to right here, and then I moved the block that direction to get as far out this direction as we could. And this black line here is the outside of the gasket. I'd like it to look better than it does here, and there's a little bit of an edge here. I genuinely don't think it would bother the gasket. I think the gasket would seal fine, but we're going to try to get it a little bit better. I rotated the cutter a little bit because it was dull. That's why the surface finish looks the way it does. But we're going to take another 0.5 thousandths here and see what we can do. But I'm going to do it the opposite direction. I'm going to move the block that direction as far as I can and bring it across, and when we get over here, we'll traverse the other way. I think that was such a light cut that we still left a little remnants of the first cut here. And if this funny business happens out here, I'm not as worried about it. But I think it's looking good. But that being said, we need to do another cut because we're not cleaning up over here. We've got some low spots. I'm happy with what we've got here. I definitely cut it a little bit close on the numbers, but they are still there. You can read them. We're good there. Gasket looks good. Filed this part down so it's even, and everything should be good. Gonna roll over to the other side now. So on this side, our sleeves actually protrude a little bit. The sleeves were kind of different lengths, so these ones actually are hanging out a little bit more. So I zeroed off, or basically ran the cutter down until we just touched the top of this sleeve, because this is the highest one. So now we're gonna basically trim off the top of the sleeves until we get level, and then our number on the z-axis of the DRO we need to go to is minus 5.1905 to make the deck height identical on this bank and this bank. So hopefully you guys remember earlier in the video we showed that this side of the deck had previously not been cut even from front to back, and that's showing up here as we have cleaned up over here on this side, but we have really only touched to about here, and you can see some waviness in the surface as well by where it's shined up already and where it's not. So we're gonna keep going. So we're 6/1000ths from our final height right now. I'm gonna do it in a 5/1000ths cut, or 5.5 cut, and then we'll do a 1/2 thou finish cut. So I'll take this to 190, minus 190. And then our finish is 51905 to match the other side. So it's gonna be a heavier cut.
After our rough cut, we made a 1/2 thou finish cut to make the deck height equal on both banks of cylinders. Once the second side of the block was decked, the final step in the process before moving over to the cylinder hone is to rough bore all of the second bank of cylinders for our 30/1000ths oversized pistons. The pistons we've opted to move forward with on this build are a forged stock replacement piston for the 396 big block from Speed Pro. As mentioned earlier, the standard size seemed to be obsolete, so we've moved to the first oversize of 30/1000ths of an inch larger. The manufacturer lists a recommended minimum piston to wall clearance of 1/1000th of an inch, although we're going to be adding an extra 1/2 to that number, bringing our final finished bore size to 4.1245 inches. With the main caps torqued on the block, we're getting set up in the cylinder hone in order to hone the cylinders to the finished bore size. We're going to be honing with a torque plate, but first we need to do a bit of setup on the machine. Using the machine setting fixture, we first shim the guides of the hone head as well as the stones to the proper size. Next, we adjust the stroke length of the machine for the proper length of the cylinders. We also adjust the different drive belts on the machine to adjust the stroke rate of the machine as well as the RPM of the hone head. Finally, we adjust the height of the engine block in order to achieve the desired overstroke on the top and bottom of the cylinder.
We've got our roughing stones in here because I'm still around 3/1000ths to go to finish size. These stones are a rougher grit. They're going to take material out more quickly, but they're going to leave a rougher surface finish. So. Right at the top, we're a little bit tight, so I'm going to dwell a little bit at the top if I can, but it's not too much. So I've used our rough stones to get us out closer to our finished size, and here's just kind of an idea of what kind of surface finish that leaves. So here you can see now we're going to switch to a little bit finer grit stone, a little bit finer grit than the stone we were just using, and we're going to sneak up on our closer to our final size here. And for reference, it might be a little difficult to tell a difference on video, but compare the surface finish of this cylinder with that of one of the other cylinders here. You can see it's a little rougher here compared to the stone we're using right here. So now just for fun, I want to show, that's the cylinder I just finished honing. So we've got 72 degrees everywhere else, and we're 74 or 75 on that one. The rest of the block is sitting around 70 or 71. So I'm going to let this cool for a little bit before I do our final honing step to make sure that we're getting an accurate size reading. Okay, so at this point, we're almost to our finished size. We've got one more stone here that we're going to use that is the finest grit size that I use, and we're going to take it to our finished size. So here, hopefully you can tell the difference. I know it's pretty subtle, but this cylinder is at our finished size with our fine stone, and this cylinder is not quite to finished size, so we still have to do our final stone on this cylinder. You can see the surface finish is just a little bit coarser compared to this. Got our cylinders to size. The last step, we do a little plateau brush that we run through the cylinders, just a few strokes, and the idea is that's going to kind of take off any of those last little broken edges that are remaining.
At that point, our first bank of cylinders is wrapped up, so we can move the torque plate to the opposite bank of cylinders and bring them to our finished size. Zero on the gauge is our minimum 1/1000th clearance, and you can see that we're within a couple of tenths either way of our 1/2,000th larger than that, which I'm happy with. With the honing process wrapped up, the machining of this engine block is finished, so it'll move on to get final cleaned before we assemble the short block for our customer. Stay tuned for more to come, and we'll see you in the next one.